So we start now. The next property is thermal property of engineering material. In case of thermal property of engineering material, it is assist the behavior of material under thermal loading. The material is subjected to thermal loading. It assesses the behavior. Now, not only the thermal loading, it may also assess the behavior of material under thermal gradient. So, when there is a subjective to thermal gradient or thermal loading, then what should be the behavior of that material? That assessment is considered in case of thermal properties of the engineering materials. Now, there are few thermal properties, namely thermal conductivity, specific heat, thermal conductivity, specific heat, then heat capacity, thermal diffusivity, These are the few thermal properties which we are going to consider. Now, in case of thermal conductivity, it is nothing but it is ability to conduct heat. So thermal conductivity is nothing but it is ability to conduct heat, and it is defined in a unit of Weber per Kelvin per meter. The unit of thermal conductivity is Weber per Kelvin per meter. Now, second one is specific heat. Specific heat is amount of heat required to change the temperature by 1 degree by 1 unit by 1 unit. So specific heat is so specific heat is amount of heat required to change the temperature of that material by say unit by 1 unit. That unit may be either degree Celsius or that may be in Kelvin. So the unit of the specific heat is joules per kg per Kelvin per kg per Kelvin. Now next, Heat capacity. So first one is thermal conductivity. Thermal conductivity is nothing but it is the ability of material to conduct the heat. If thermal conductivity is more, it means that the transfer of heat energy from one point to another point is on a faster rate. Second one is specific heat. Specific heat is amount of energy or amount of heat required to change the temperature of that particular material by one unit. That unit may be either degree Celsius or Kelvin. Second one is next. One is heat capacity. Now heat capacity is a product of, this is product of density, and this is a product of density and specific heat. Heat capacity, it is a product of density of that material into specific heat, and the unit of this specific heat is, sorry, heat capacity is the unit of this heat capacity is, that is joule inverse into kg per meter cube. Now this kg get cancelled. So therefore, the unit is joule Kelvin inverse into meter cube uh, per meter cube. This is the unit of this heat capacity. Now the last one is thermal diffusivity. But you understand this, how we calculate the unit? It is nothing but it is a specific heat into density. Now the specific heat unit is this joule per kg per Kelvin. We multiply by the unit of this density. Unit of density is kg per meter. Now this kg get cancelled. This kg get cancelled, and therefore the unit is joule per Kelvin per cubic meter. Now last one is thermal diffusivity. Now thermal diffusivity, it is a ratio of thermal conductivity to heat capacity. So thermal diffusivity, it is a ratio of, thermal diffusivity. It is a ratio of thermal conductivity to heat capacity. It is a ratio of thermal conductivity to heat capacity. And the unit of this diffusivity is meter square per second. The unit of this thermal diffusivity is meter square per second. Now next one is when material is subjected to, what? Thermal loading. When material is subjected to thermal loading, as well as static or dynamic external load. When material is subjected to thermal loading, it means temperature as well as static or dynamic load. Static or dynamic load. In that case, in that case, in that case, we measured the property. We measured the thermal property in terms of coefficient of thermal expansion. Coefficient of thermal expansion. When we consider the coefficient of thermal expansion, when your material is subjected to thermal load, that is the temperature, either decrease or either increase, plus there is some static or dynamic load exerted over it. Then because of this two, there is a change in the shape of that particular material takes place, and how much that shape will be changing. That shape change we can assess through this property, which is called as coefficient of thermal expansion. Now there is one more property which we consider in this case, that is thermal shock resistance. Thermal shock resistance. When material is subjected to thermal loading, at that time, if there is an impact load, if impact load is occurred to that material, then what is the resistance that material offered to that impact load, that will be calculated with the help of this property, which is called as thermal shock resistance. So in case of coefficient of thermal expansion, we measure the change in dimensions. Second, thermal shock resistance, we measure the ability of material to sustain the impact load when that material itself is subjected to what? Thermal loading. When that material itself thermal loading. Now the coefficient of thermal expansion has a unit of Kelvin inverse. The coefficient of thermal expansion has the unit of Kelvin inverse, and this thermal shock resistance given by the formula K into sigma T divided into 1 minus mu divided by alpha T. This is thermal shock resistance, coefficient of thermal shock resistance, where K is a thermal conductivity. This is thermal conductivity. Sigma T. The sigma T, it is the maximum tensile stress. Mu is a Poisson's ratio. Alpha is coefficient of thermal expansion. Alpha is coefficient of thermal expansion, which is this coefficient of thermal expansion, and E is a modulus of elasticity, that is Young's modulus. So coefficient of thermal shock resistance is calculated by K into sigma T, 1 minus mu alpha into E. And this thermal shock resistance assesses the impact of material subjected to thermal loading and When the impact load is directly occur for short period of time, then what should be the effect? That effect is measured through this. Now we see this all terminologies related to thermal expansion and thermal conductivity, many more terminology in detail when we are going to start our topic of thermal insulating material. At that point, we are going to reconsider these all the properties. We redefine all these properties, and we will assess how we can assess the thermal insulation capacity of that particular material by utilizing this property. Okay, so that time we are again going to deal with this property. Right now, just understand these are the few properties which are to be essential. The next one is type of engineering material. Type of engineering material. And the first one is metal and alloy. First one is metal and alloy. Now we know that from the chemistry, metal has free valence electron. Now metals, those metals which have free valence electron, and this free valence electron is responsible for good thermal and electrical property. This valence electron is responsible for good thermal and electrical property. Now, metal lose these free valence electron. Metal lose this free valence electron. When you are going to lose that free valence electron, then that metal itself become positive ion. So become positive ion. Then that metal become positive ion. Are you getting? Metals are those materials which have free valence electron. Now, according to the chemistry of physics, that free valence electron responsible for the thermal and electrical conductivity of that material. Now, what happened? This free valence electron is lost by that particular metal, and after losing that electron, metal become positive ion. Now, the electrostatic bond between electrostatic bond between what? Valence electron, that is lose valence electron, and positive ion. Electrostatic bond between these two. Electrostatic bond between loose valence electron and positive ion. It is called as metal ion. It is called as metal ion or metal bond. So this is called as metallic bond. This is called as metallic bond. Now once again, metal are those materials which have free valence electron in their outermost orbit. That valence electron is responsible for what? That valence electron is responsible for good thermal electrical conductivity of the material. Now, what happened? Metal lose that free valence electron. When metal lose that free valence electron, it becomes positive ion. Now, the electrostatic bond between what? Electrostatic bond between this loose valence electron and positive ions is basically called as metallic. Is basically called as metallic bond. Please write down the things in your notebook. What are the things we are writing? Write down at the blackboard. It is essential. In case of your examination, we don't want answer in terms of lines after lines. We want some logical interpretation of your answer. Now, in case of engineering material, metals are generally used in the form of alloy. In case of engineering material, metals are generally used in the form of alloy. Now, alloys, it is a combination of, it is combination of, it is a combination of, it is a combination of two or more material, two or more material, and the condition is, it is a combination of two or more material, and the condition is at least one material is metal, and the condition is at least one material is metal. If you are compromising, say, intermixing with three material, out of that three, one should be at least a metal. Then that material is called as alloy. Then that material is called as alloy. And what is the utility of this alloy? What is the advantage of this alloy? The advantage of alloy is it enhances the property of material. It enhances the property of material. And due to the enhancement of property of material, the ability to use that material for specific purposes increases. That is, the chances of ability to use that particular alloy to specific use is increases. So therefore, in case of engineering material, instead of utilizing metal as a single element, we are utilizing intermixing of those materials called as alloy, and that alloy is used for specific purpose. For example, steel is alloy. Now steel is a combination of iron plus carbon, plus some other alloying material, Steel is a alloy. Then second one is brass. It is a combination of copper plus zinc. It is a combination of copper plus zinc and bronze. and this bronze is copper plus tin. It is a combination of copper plus tin. Secondly, this material is mainly used in construction. This material is mainly used in construction. Brass, this material is used for some plumbing elements. This material is used for some plumbing elements. So we are mainly dealing still brass. There are some plumbing elements or plumbing components which is made of brass. So in civil, we are utilizing these two alloys preferably. Now, this alloy are very good or very effective. Instead of good, it's a very effective blending of these alloys are very effective blending of what? Mechanical. Very good blending of mechanical and thermal properties. So very good blend of mechanical and thermal properties. So we are utilizing alloy instead of utilizing single metal element. Now, the selection of metal. Selection of metal and alloy. Selection of metal and alloy is depend upon is depend upon it is depend upon few properties like it's depend upon what hardness, toughness. It is depend upon hardness, toughness, strength. It is depend upon hardness, toughness, strength. Very much important is a dimensional stability. It is again depend upon dimensional stability because if that particular alloy or metal is not dimensionally stable, then it is not feasible to use. So dimensional stability. Then formability. The next one is formability. Formability means that metal or alloy should able to take the shape which we require. So formability. Second one, it's also depend upon the conductivity of heat and electricity. It is also depend upon the conductivity of heat and electricity. So on these the selection of that metal or alloy for specific purpose is decided. On these properties, the selection of that metal or alloy is decided. Second one is ceramic material. Second material is ceramic material. Now ceramic material are clay minerals. They are clay minerals. They are clay minerals. Second, ceramic materials are non-metallic. Ceramic material are non-metallic. Non-metallic means it does not have valence electron in their outermost orbit. They are very good resistance or very good. They are very good or say excellent resistance to very excellent resistance to thermal and electrical conductivity. They are very good or very effective resistance to thermal or electrical conductivity. Means ceramic material is used as an insulator for electrical as well as thermal loading. Second, this ceramic material are used at high temperature. Ceramic material used at high temperature, susceptible construction, high temperature susceptible construction like chimney, kiln, etc. That is chimney, kiln, etc. And for this two, that is chimney and kiln construction, we are utilizing ferro cement. We are utilizing ferro cement, and ferro cement is a ceramic material. Ferro cement is ceramic material. Secondly, glass is a ceramic material. Secondly, glass is a ceramic material. Is ceramic material, and we are utilizing glass in case of civil engineering. We are utilizing glass in case of civil engineering for window, sometimes for railing, etc. But specifically, we are utilizing glass for window. Now, the selection of this ceramic material, depends. The selection of ceramic materials depends on following properties. The selection of ceramic material is depend on following properties. Second, low conductivity, that is thermal as well as electrical. Low conductivity, that is thermal as well as electrical. Second one is low tensile strength. It has low tensile strength, but but it has high compressive strength. High compressive strength. It has high compressive strength. Secondly, ceramic material are brittle in nature. Ceramic material are brittle in nature. Second, ceramic material are abrasion resistance property. Ceramic material are have or possess abrasion resistance property. It has good hardness. It has good hardness. Remember, it has very low toughness. Why very low toughness? Because it is a brittle material. It is a brittle material. The area under stress strain curve is very less, and toughness is nothing but it is a area under stress strain curve. That is strain energy, retain capacity of the material. That is strain energy, retain capacity of the material. And ceramic material is basically used for thermal and electrical insulator. Ceramic material are used in case of thermal and electrical insulator. Now next one is polymer. Polymer. Now polymer is, it is a chain of molecules. It is chain of molecules. Chain of molecules connected by connected by covalent bond. Now covalent bond means there is a sharing of electrons. Sharing of electrons. Sharing of electrons. In case of metal, there is no sharing of electron, there is a losing of electrons. Electron is loosed by the metal element to form the positive. But in this case, there is a sharing of electron, so therefore there is a covalent bond, and these covalent bonds are formed a chain of molecule which is called as polymer. Which is called as polymer. Now, there are three types of polymer. There are three types of polymer. There are three types of polymer. First one is, there are three types of polymer. First one is thermoplastic. Second one is thermoset. Second one is thermoset. And third one is elastomer. Third one is elastomer. Now, in case of thermoplastic, recycling at any point of time, recycling, instead of saying recycling, it is remolding. Instead of recycling, it is remolding. Remolding at any point of time is possible. Is possible. Now, what do you mean by remolding? Remolding means, suppose you are going to, this is a thermoplastic. Right now it is a rectangular block. Now we want to remold this. Means we have to melt it and then form another shape. Then that will be possible in case of thermoplastic. In case of thermoplastic, it will be possible. Second one is thermoset. In this case, remolding is not possible. In this case, remolding is not possible. So, remolding is not possible. Remolding is not possible. But up to its curing of this, when we are going to form this material, that is thermoset plus thermoset setting polymer, then up to its curing means after mixing there has some time required to settle down or cool down this particular material, that is thermosetting material. Then within that, up to the curing period, we can remold it. But once the curing period is over, the remolding is not possible. The remolding is not possible. Means it is not possible to have the recycling of that element. Last one is here, elastomers. Elastomers provide very high elastic deformation, or it possesses very high deformation when subjected to very high elastic deformation, subjected to loading. Very high deformation when subjected to loading. Now these elastomers, we are utilizing these elastomers as a bearing material. In case of which this is pier. In case of this is pier, and then there is a pier cap. And over this pier cap, we place the deck of bridge. This is the deck of bridge. Then this gap, we are providing the bearing. There are various types of bearing, but we are providing the bearing so that horizontal thrust should be sustained by this bearing. So to minimize the horizontal thrust because of the vehicular movement, this bearing is going to be provided. Now this bearing is many types. One of the type is a elastomeric. It is manufactured by utilizing this elastomers, and the name of that bearing is called as neoprene bearing. Neoprene bearing is made up of elastomers. Okay, it is already done. Now, in case of polymer, polymers are electrical resistance. It has good electrical resistance, but it has very poor thermal resistance. But polymers are low weight. The weight of polymers are low. It has low conductivity and is very poor thermal resistance. It has electrical resistance, low conductivity, but it is prone to higher hazards. It is prone to fire hazards. It has low hardness. It has low hardness, low strength, low tensile strength. It has low tensile strength. And very much important, it has very poor dimensional stability. Dimensional stability. It has very poor dimensional stability. Why it has very poor dimensional stability? Because it has low strength capacity as well as it is susceptible to the fire hazards or thermal or electrical resistance. So therefore, it has very poor dimensional stability. Here it has in plastics in the form of PVC, polyvinyl chloride, UPVC, CPVC in case of plumbing system and many more. Okay. So this stop.